So let's spend a little time and look at exactly how TCP works with determining what the size of the window should be. Remember, there are two window parameters that have to be tracked. One is controlled by the receiver, the person. We're going to talk about you and the other guy. You're the sender, the other guy is the receiver. One is controlled by the receiver, and that is typically driven by how much buffer space, how much memory space the receiver has. And the receiver size will advertise to you his receiver window. Now you will also advertise to him what your receiver is, because remember, this is a two-way conversation. But from a standpoint of just thinking about your process and how much you can send, you pay attention to what the other guy sends you in his receive window. And that number is included in every TCP packet you get from him. Even every acknowledgement that you get from him has an updated receive window. So you're constantly receiving from the other side how much buffer space they have. And it doesn't actually typically change that much, but it can. It can actually change quite a bit. I've seen it shift for a number of reasons. We're not going to go into all those. All right, the other thing you keep track of is something called the congestion window. And this is your measurement of how busy the network is. If the network is really congested, then you're going to make your congestion window very small. You're going to be a good citizen. You're going to slow down. But if the network is just flying, you sense that it's really working well, then you're going to grow really large. And you have to use the smaller of these two numbers. And what we do is we are going to start out, we're going to have a process called slow start. And it's called slow start because you start out slow. But it grows very quickly. It actually doubles every round trip time. So it can quickly get to a very large number, and your congestion window, which is what's growing here, can quickly become bigger than the other guy's receive window. And so initially your congestion window is typically smaller than the receive window, so you use your congestion window. Eventually that grows very large, and then you start using the other guy's receive window as your limiting factor. And so the sender remembers the size of the receive window set by the receiver. There's a receive buffer on the other side, and that you have to track the last byte that was received and placed in the buffer. And then that usually tells you how much buffer space the other guy has. And I said that very poorly. The other guy tracks his last byte received, and he knows how much memory he has. And then what the sender does is he tracks what's the last byte that has been sent and what's the last byte that has been ACKed. And the difference, if the last byte ACKed is quite a bit lower than last byte sent, then you have a lot of data in transit that's not been acknowledged. If they're very close, then that tells you you're getting quick acknowledgments, and so there's not a lot of data that hasn't been acknowledged. All right, so then we have what's called congestion control. You keep track of both of these, and you have the receive window and the congestion window. I just talked about those. The smaller of those is the actual sending window, and the congestion window grows or gets reduced based on what happens. And here are the rules for that, and I'm going to actually do a slideshow on this one, so it'll show up just a little better on your screen. We have what's called additive increase. Let me grab a highlighter here. The process is called slow start because it starts out slow. It's a multiplicative increase. It's an additive increase, and we'll talk about how this works. But remember the MSS, that is the maximum segment size. Whoa, I'm using the wrong size here. Let me grab a pen, a black one, I think. Max segment size. That's not a pen. There we go. Ooh, there we go. And that's red, of course. There we go. The maximum segment size. That typically is going to be 1500, but it might be something else. We're going to do an example on the next slide, blank slide. So we start out with a single segment size, and every time we get an acknowledgement, we grow the congestion window by one maximum segment size. And so that's this part right here. Every time we get an acknowledgement, we grow our congestion window, because every time we get an acknowledgement, that tells us, hey, things are going well, and so we're going to grow the size of our window. There's this other thing called a threshold, and I'm going to have to go to the next slide to really show this to you. Here is a graph, and let's set the threshold at 65,000 bytes. All right, so that's 65,000. And let's say that our MSS, maximum segment size, I'm just going to make it 1,000 because that'll make it a little easier for me to do the math here. And initially, this is going to be 0 bytes. Here's 65K, and there's bigger. Initially, we're at 1,000, so we're down here. And we send a window. What's the window size? Is 1,000. We send 1,000 bytes, and we get an acknowledgement. And so now we can send 2,000 bytes. So in the next time we have data to send, we can actually send 2 packets. We can send one at 1,500 and one at 500. We send those 2 packets, and they both get acknowledged. And at each acknowledgement, we grow by 1,000. So this is the start, and this is after one round trip. We sent a packet, we got an acknowledgement. And the next one, we send 2 packets, we get 2 acknowledgements, and now we grow, we grow up to actually 4,000. You see, we doubled. And so the next time we send 4, and we're going to grow to 8,000, and the next time we're going to send 8, and we're going to grow to 16,000. And so this is actually going to double every round trip time, and it's going to very quickly grow up to be, it'll grow to 64,000, and then it'll actually go to 128,000. And this threshold is when we say, hey, after we cross the threshold, we're not going to grow exponentially anymore, and we have a new formula. So initially, it grows like this, and then we grow linearly. And so we're going to slow that down. So let's page up here. Oops, page up. And you can see that right here. There are 2 growths. We have exponential growth during our slow start phase, and we have linear growth during the congestion. And the key number is this threshold. That line tells us when we change over from doubling every round trip time to growing by a single MSS every round trip time. And so that's going to do it for this particular lecture. We'll do a couple of examples in the next one.